All right, let's cut the fluff. React isn't that complicated once you stop overthinking it. In React, components are the core of everything. They're like building blocks, buttons, inputs, entire pages. Components are reusable, so you can make them once and use them as many times as you want. A React component is just a JavaScript function that returns JSX, JavaScript in disguise. JSX lets you write HTML-like code in JavaScript, but remember, it's not plain HTML. You'll need to use camel case for attributes like class becomes class name. JSX is powerful because it allows you to mix in JavaScript. Need to display dynamic data? Just wrap it in curly braces. It lets you insert variables, expressions, or even functions directly into your markup. One key thing to remember, React components can only return one element. So, if you have multiple elements, wrap them in a div or use a React fragment to keep things clean. Props are how we pass data into components. It's like giving a component custom settings. You create a prop, give a value, and then use it in your component. You can even pass other components as props. And that's where composition comes in. With the children prop, you can pass child components into a parent component. Think of it like filling a wrapper component with dynamic content. The key prop helps React identify components in lists. When you're mapping over an array of items, each one needs a unique key. Without it, React can get confused, so it'll throw a warning. Rendering in React means updating the UI whenever something changes in your app. But React doesn't directly change the real DOM right away. Instead, it uses the virtual DOM to make things faster. The virtual DOM is a lightweight copy of the real DOM. When state changes, React updates the virtual DOM first, checks what's different compared to the previous version, and then updates only the changed parts of the real DOM. This process is super efficient and keeps your app fast. React handles user actions like clicks, key presses, and form submissions using event handling. Events in React are handled with camel case. So onClick, onChange, or onSubmit are how you capture user interactions. For instance, you can show an alert on a button click by attaching the onClick prop to a button and linking it to a function that triggers the alert. State is like a snapshot of your app's data at any point in time. React components use state to track things that change over time, like how many times a button is clicked. To manage state in a functional component, use useState. This hook returns a state variable and a function to update it. React automatically re-renders a component when state changes, ensuring the UI stays in sync with your data. Control components are when React controls the input value. For example, an input field with a value set by React state is considered controlled. Here's how it works. The user types and set value function puts what the user typed into state. The state value is then updated, and finally the input uses that updated state as its value. Uncontrolled components let the DOM handle the input state directly, and React just gets the reference via a ref. Control components offer more predictable behavior, especially when you need to interact with form data or validate inputs. A React hook allows us to hook into React features, such as state and lifecycle features, within function components. Here are a few key ones. State hooks, like useState and useReducer. It helps you manage local state within React components. Effect hooks, like useEffect, let you connect with external systems like browser APIs. It performs side effects like fetching data when a component mounts or updates. Ref hooks, such as useRef, let you reference things like HTML elements and access and modify DOM elements directly. Context hooks, such as useContext. It shares data across components and let you use data passed through React context. And performance hooks, like useMemo and useCallback, which can optimize performance by preventing unnecessary work. You'll eventually touch all the React hooks, but most of the time, your go-to trio will be useState, useEffect, and useRef. They cover 90% of what you'll need in day-to-day components. Purity in React means a component should always render the same output given the same input. It is just like a pure mathematical function. Given the same input, you always get the same output. To keep a React component pure, avoid modifying variables or objects during rendering, because this can lead to unexpected behavior. To help make sure we don't run into errors like this, we can use something called strict mode. React Strict Mode helps you catch mistakes like this by warning you about unsafe lifecycle methods and other potential issues during development. Just wrap your app with it, and React will warn you when you're doing something sketchy. Sometimes, a React app needs to interact with things outside of itself, like the browser or server. These interactions are called effects or side effects. The cleanest way to handle them is inside event handlers, such as making an API request when a button is clicked or a form is submitted. But if you can't run your effects within an event handler and you need something to happen automatically, like fetching data when a component loads, you can use the useEffect hook. Effects let your components step outside the React world in a controlled, predictable way. Sometimes you want to step outside of React Virtual DOM and work directly with the real DOM elements. Refs let you access and manipulate DOM nodes without triggering re-renders, unlike state. A common use case is focusing an input field, scrolling to an element, or measuring its size. These are low-level operations that React doesn't manage for you, so refs are the escape hatch. To use one, create a reference with useRef, then attach it to a JSX element via the ref prop, and you can access the DOM node via ref.current. It's much easier to reference the actual DOM element instead of attempting to do it the React way. Context is a powerful tool for managing state and share data across deeply nested components in React. In large apps, passing props down through multiple layers can get messy, especially when some components in the middle don't even need the data. This is called prop drilling. Context solves this by letting you bypass prop drilling entirely and let you pass data down through your app without having to pass props through every level of the component tree. To use context, create a context object, wrap a parent component with a context provider, put the data you want to share inside the provider. Finally, access that data in any child component using the useContext hook without needing to pass props manually. Normally, components are rendered within their parent's DOM tree, but sometimes that parent might have styles that prevent pop-ups from displaying correctly. Portals solve this by allowing you to teleport the component to another part of the DOM, usually a top-level container placed outside the root React element. This is useful for things like modals, tooltips, or drop-downs that need to appear above other content. To create a portal, you use createPortal function. Child is the JSX you want to render. Container is the DOM node you want to render it into. Here is an example. Use the createPortal function. Pass your component you want to render, and choose the DOM node where you like your React component to appear. Suspense is React's way of handling components that take time to load, such as components fetching data or being lazily loaded. With Suspense, you can show a fallback, like a loading spinner, while waiting for the data or component to load, which improves user experience. Error boundaries catch JavaScript errors in components and prevent your whole app from crashing. Just wrap your components in an error boundary to keep things running smoothly. If an error occurs, you can show a fallback UI instead. This is great for graceful error handling in your app.